So we are going to continue with 9.5. In 9.5b, unlike 9.5a, we have a few little tricks we have to use in order to solve the equations. They're not solved quite so just using our rules of algebra. So if you see a problem like this, and you'll notice that we've got tangents, we've got secants, they are not touching that we could like factor them. Here's the technique you want to do. First thing you want to do is you want to get it equal to 0. So I want to take this stuff here and I want to subtract it and move it to the other side. Okay. So the first thing I'm going to do is I am going to subtract 1 from both sides, and I'm going to add a 2 tangent of x to both sides. Now there's no like term to match a 2 tangent of x, so it's just going to hang out the problem. So it's equal to 0. Now I'm going to look and see if what I have there is a factorable quantity. Now if this wasn't here, and this middle thing had both a secant and a tangent in it, it might be factorable the way that it sits. The way that it is right now, there is no way to solve this equation. It's a 2-variable equation, a secant and a tangent, and so we can't solve it. You just can't. So here's what we have to do. Here's the trick. We have to find some relationship between a secant and a tangent. Does anybody know our Pythagorean that has a secant and a tangent in it? Can anybody tell me our Pythagorean that has secant and tangent in it? Yes.
1 plus tangent equals secant.
Now it has to have the squares on it, and 1 plus tangent squared equals secant squared. Some things we did on the last quiz. Some people were trying to replace a 1 plus tangent equal to a secant. It only works with a squared on it, so be careful with that. But that's what we're going to use to help us. Now, the trig function I see most of are tangents. The one that I want to try and replace is secant squared. Now, secant squared is equal to the quantity of 1 plus tangent squared. So watch your algebra. What we're going to do is we are going to write everything else the way that we have it. In parentheses, we are going to replace secant squared with a 1 plus tangent squared. Now, the reason we have to use parentheses is because of the fact that that negative that's sitting there has to distribute, and you have to subtract from both things. So let's distribute the negative now. So we have 2 tangent of squared plus 2 tangent of x minus 1 minus the tangent squared of x plus 2 equals 0. Now a tangent squared and a tangent are 2 different things. So we can only combine this like term with that like term. And we get tangent squared plus 2 tangent of x. These are like terms. Positive 2 minus 1 is plus 1 equals 0. Now, once you have it equal to 0 and as simplified as possible, and if our only trig function is one particular function, it's in factored, it can be factored, we're going to do our little substitution at this point. Now you don't have to, I just think it's a good way to go. And so at this point, every place that I see a tangent, I'm going to replace it with a u. So this would be u squared plus 2u plus 1 equals 0. Now the reason we do that, the only reason we do that is so that the algebra that was hidden becomes a little more visible to us. So hopefully you recognize that that is a factorable quantity, u plus 1 times u plus 1. And then don't forget, once it's in factored form, by the zero product property, we can set each one of those equal to 0 individually and solve them. Now we get -1 both times, so you don't have to do it twice. And then, and only once you have the variable equals a number, do we stick the trig function back in. So we get that the tangent of x equals -1. Now, once you have your trig function back in there, we have to ask ourselves, where on the unit circle is the tangent equal to -1? So if we look on the unit circle in quadrant 2 and in quadrant 4 is where the tangent will be negative because the sine and the cosine are opposite signs. So this 45 over here, you might recall, is 3 pi over 4. This 45 right here is 7 pi over 4. And so our answer is 3 pi over 4 or 7 pi over 4. Now, you don't have to do the u substitution step. If this thing, you want to write that as the tangent of x plus 1 times the tangent of x plus 1, that is an option. I'm just showing you the u substitution method because it does kind of make that algebra pop as we go through that process, okay? So you'll notice that in order to solve this trig function, we had to know those identities. That's why those are still so important that you know those. Okay. Do we have any questions at all about example 1?
How did you get x equals?
So remember, once you get to the point where you have your trig function equals a number, that's when you ask yourself, where on the unit circle does that happen? So the tangent is 1 or -1 at the 45s. It's negative here and here. And so specifically because it would be square root of 2 over 2 divided by negative square root of 2 over 2. So that is, so at this point, you have to know your unit circle or look at your unit circle to get those final answers. Any other questions? Okay. Let's look at another one. One last example. We are going to probably look at some of the homework together. Okay, anyway, let's look at this example. It says find all the solutions of 1 plus the cosine equals the sine. Let's try to get this equal to 0. If we try to get that equal to 0, I'm just going to do it over here on the side because it's not going to be helpful to us. If we write it like this, that is not factorable. It has two separate things. Nothing is helpful to us. But what we do know about the sine and the cosine is one of our Pythagoreans. Can anybody tell me what's the Pythagorean we know about sine and cosine? If you square them and add them, they're equal to 1. So we know the fact that sine squared plus cosine squared is equal to 1. Now, one of the things I said during the last example was that if it doesn't have the square on it, we can't use the Pythagorean. So this particular problem, the way that it sits, it doesn't have the square on it. But if we do the same thing to both sides of an equation, we get an equal result. So what we can do is we can square both sides and it doesn't hurt that equation. Be careful when we square this side, that's 1 plus cosine times 1 plus cosine. And here that's just sine squared. Now, let's actually FOIL that out. 1 plus cosine times 1 plus cosine is 1 plus 2 cosine of x plus cosine squared of x. Now, I haven't shown you that all the FOIL. You were sitting here in pre-calc. I hope you know how to do that. 1 times 1, 1 times cosine, cosine times 1, cosine times cosine gives you this result. Now, on the left side of our equation, we have only cosines, one of which is not squared. On the right side of our equation, we have only sines, which are squared. So what I'm going to do is I'm going to replace this with something related to cosines. So what do we know? Well, if we do a little bit of rearranging, remember, you know that sine squared is 1 minus cosine squared. So this, replace it with the other trig function. And now let's move everything around so we have everything on one side equals to 0. So how do we do that? Well, let's subtract 1 from both sides. Let's add a cosine squared to both sides. And I'm going to put it in descending order. Descending order, highest power to lowest power, is usually helpful when it comes to factorization and just the way we think about it. So my answer before I do my u substitution is 2 cosine squared of x plus 2 cosine of x equals 0. Now, at this point, you can factor as it sits. You know, you could factor out a 2 cosine and go from there. But so that we don't lose track of the algebra, I am going to do a substitution. I'm going to let u equal the cosine of x. So I get 2u squared plus 2u equals 0. So I've taken out the cosine of x's and I've replaced them with u so that I don't get lost for the algebra. And we could have even done that about the 4th step down. That wouldn't have been a bad spot to do it, maybe right here once they all match. Don't do it before that because we got to get that sine squared out of the problem. Okay, so this is not factorable in the sense that it is going to be factorable into two main like parentheses. But does anybody notice what is in each of those things? A 2 is in each of those things. So we're definitely going to factor out a 2. What else is in each of those things? A u. We can only take out the lowest power, so we can take out a plain old u to the first power. Now be careful. When you divide by 2u, we have to account for the fact there were 2 terms there. We should have 2 terms in our parenthesis. If I take out a 2 and a u here, I'm left with a u. If I divide this by 2u, I have to have a 1 placeholder there so that when I distribute again, I get what's right there. So don't forget the 1. You guys are notorious for forgetting that 1. Don't forget that. That is your placeholder so that if you distribute again, you'll get what you started with. Remember, the way to check division is multiplication. So if I multiply that in, I better get what's here or I didn't divide right. Okay, so now, or again, by the zero product property, I could split it apart. So 2u equals 0 or u plus 1 equals 0. Get it equal to a number. So here if I divide by 2, here if I subtract 1. Only when it's equal to a number do I want you to put the trig function back in. So we have the cosine of x equals 0 and the cosine of x equals -1. Now remember, at this point, the only way to finish this and answer the question is to know our unit circle. On the unit circle, the cosine is equal to 0 in 2 locations. At pi over 2 and at 3 pi over 2. So that's what the answer is here. So the cosine is equal to 0 in 2 locations on our unit circle, at pi over 2, 90 degrees, and at 3 pi over 2, 270. Please use radians when answering these questions. Finally, cosine of x equals -1. There's only one location on the unit circle where the cosine of x is equal to -1, one loop around at least, and that would be at pi. So we end up with 3 answers to this: pi over 2, 3 pi over 2, or pi. Now, how could we check if we were right? I would not check in here because you've manipulated the equation and you might have done something wrong. You should be able to put those right here and get correct answers. Well, 1 plus the cosine of pi over 2 equals the sine of pi over 2. Yes, 1 plus 0 equals 1. You should be able to plug those back into the original. Because we squared them, it's a good idea to check them. Pi over 2 works. That one I just checked, it does work. 3 pi over 2, the cosine of 3 over 2 is 0. The sine of 3 pi over 2 is -1. That one doesn't work because you squared a negative and you got a positive. If you plug in pi, we get 1 plus -1 equals 0. That one works. So we actually start out thinking there was 3 answers, but anytime you put a square into a problem that wasn't there, you do have to check your work because you could get what's called an erroneous solution that seems like it works, but when you plug it back into the original form, it doesn't work. Okay, so that is one where we had to square both sides. Do we have any questions about that one? If you plug these x values back in the original, just using the unit circle, let's think of pi over 2. 1 plus the cosine of pi over 2 equals the sine of pi over 2. Is that right? Well, that's 1 plus 0 equals 1. Yeah, that one's right. But if you stick in 3 pi over 2, you get 1 plus 0 equals -1, which isn't right. So it's just, again, using your unit circle values. You have to know your unit circle, or this is not going to be fun, or at least have a picture of your unit circle sitting there next to you as you do this process, okay? So that is our last kind of new type of example. So now let's look at our 9.5b homework. So let me give you some hints so that you can do this. For problems 1, 2, 3, and 4, please tack on to your answer, just write plus 2n pi. That's going to account for the all values. So just tack on a plus 2n pi. That'll fix the all values. All chapter or 9.5 homework is due Thursday by midnight. So tomorrow by midnight, these are due. Okay, just so you know that. So there's some little hints I've put up there for you so you can kind of know kind of where to get started. And I'll leave that up there for you. We will discuss these more, maybe in the next few minutes. So try them, and then we will go over some more tomorrow. I'll answer any questions you have tomorrow.